So this is grade 9 math, Pythagoras Theorem. So what we're talking about here today is we're talking about Pythagoras Theorem, and it only works for right angle triangles. And what a right angle triangle is, it's a triangle that has a 90-degree angle. So if you look down here, you'll see between A and B, that little box in the corner represents 90 degrees. For this to work, it has to be a right angle triangle. If it's not, it doesn't work. Definition-wise, hypotenuse is always the longest side of the triangle. And if you look, it's across from the right angle. So the hypotenuse is there, and these two shorter sides, which are sometimes the same length, sometimes different lengths, are known as legs. So here's the basic breakdown of Pythagoras theorem, and these letters are just represented upon this triangle. You can use any letters you want. C squared equals A squared plus B squared. So what we're looking for is the longest side is equal to the two shorter sides squared and then added together. Now these two here are the opposite. If we're looking for a leg, a shorter side, or a shorter side, we have to square the longest side and then subtract another short side, square the longest side and subtract another short side. Okay, and again, this only works for right angle triangles. So let's look at an example. Flip the page and go to page 2 there. So proving that Pythagoras theorem is correct. So this is just a representation of, here's a triangle. We have two legs here, A and B, and we have C, 5. And it really, A and B, these could be backwards, right? This could be B and this could be A. It doesn't make a difference. So here's the formula. C squared equals A squared plus B squared. So we just plugged in the numbers. So 5 squared equals 3 squared plus 4 squared, right? We know already squares, right? 5 squared is 25, 3 squared is 9, 4 squared is 16. And then we add this side, 9 and 16 is 25. So you can see the left side right here equals the right side. So it's just a proof that Pythagorean theorem works. Now, let's work an example through with different numbers. So again, right angle triangle, there's our box. So C is the hypotenuse, and it doesn't matter how we label A and B, these could be backwards. And what we're looking for in this case is we're looking for the longest side. So write out the formula, C squared equals A squared plus B squared. Plug in the numbers, 17 squared and 11 squared, and these could be backwards, it makes no difference, right? 17 squared is 289, 11 squared is 121. Add them together. Now, you have to remember, like the opposite of addition is subtraction, the opposite of multiplication is division. The opposite of squaring something is taking the square root of it. So we have to square root both sides. So the square root of C squared right here is C, and the square root of 410 is a big long number here, and these dots just mean it goes on forever. We'll just go to one decimal place. So one decimal place, we look at the 2, then we look to the 4. If it was a 5 or greater, that 2 would round up to a 3, but since it's 4 or less, we keep it at 2. So in this case, C is 20.2. Okay, and that's finding the longest side. Okay, go to the last page, and we're going to find some shorter sides. So in this one here, again, it's a right angle triangle, so this will work. We have B and we have C. So we have the longest side, so we're looking for a shorter side, so we got to use a different formula. When you're looking for a shorter side, you're going to subtract. When you're looking for a longer side, you're going to add. So we just set up the formula, A squared equals C squared plus minus B squared. Plug in the numbers. 29 squared is 841, 17 squared is 289. Subtract these two, then you get number 552. Now you remember, that's not the right answer. We have to take the square root of both sides. So the square root of A squared is A, square root of 552 is 23.4946, and so on. Now look at this one. We're going to deal with the 4 here. So we go 1 to the right and look at the 9. That is going to take that 4 and round it up to a 5. So then we end up with 23.5. And that makes more sense. Like if you look at the numbers, 29, 17, and 23.5, one of them sure can't be 552. So don't forget to take the square root at the end there. Another one here. We have A, and we're looking for B. We have C, so we're looking for a shorter side or a leg. So we're going to use B squared equals C squared minus A squared. And again, these letters could represent anything. You can use E, F, and G if you want. It doesn't make any difference. Plug in the numbers. 13 squared, 5 squared. So 13 squared is 169. 5 squared is 25. Subtract them. Take the square root. Now, this one was actually really nice. It came out with no decimals, right? It was a perfect square. So sometimes they're going to come out as decimals like this one, this 23.5 right here, right? And sometimes they're going to come out as beautiful, lovely numbers like that. Don't be surprised when you get them either way. So things to remember here. The legs are the shorter sides. The hypotenuse is the longest across from the right angle. If you're finding the hypotenuse, you're going to add. If you're finding a leg, you're going to subtract. That's the main key to take from this one. Okay.